Okay, today what we're going to talk about is independent and dependent probability of compound events. So let's make sure that we understand. A simple event, okay, a simple event, write this on top. A simple event is just like kind of what we were talking about in class today, rolling a die. The probability of getting a 5 when you roll a number die is going to be 1 out of 6. That's what we call a simple event. It's only one event occurring. All right, tossing a coin. The probability of getting heads is 1 out of 2. Picking a card from a deck of cards. The probability of that being a 3 of hearts is 1 out of 52. So that's what we call a simple event. It's just one thing. Compound means more than one. Think about compound words. That's that you've learned about in English class. Compound events and probability means more than one. So first of all, we're going to talk about independent probability. The probability of the first event does not change the probability of the second event. So for example, the probability, that's what that P means. The probability of, well, it says rolling a die and flipping a coin. The probability of getting that 3 is going to be 1 out of 6. And then getting heads would be 1 out of 2 because there's 2 sides on a coin. All we do is we multiply that together and we get 1 over 12. And of course we can change that 1 over 12 into a decimal by doing 1 divided by 12. And we get 0.08 with 3 repeating. And then as a percent, that would be 8.3%. Okay, so let's go ahead and take a look at another example of independent. There are 5 yellow marbles, 1 purple, 3 green marbles, and 3 red marbles in a bag. Once a marble is drawn, it is replaced. That's why it's independent. It's replaced. Find the probability of each outcome. Okay, so a purple, all right, so how many purple do we have? 1 purple. So 1 out of, the total number of marbles is 5 plus 1 is 6, plus 3 is 9, plus another 3 is 12. So it's 1 out of 12. Then it says a red marble. The probability of, because we're replacing that marble, it's going to be times 3 out of 12. Now, if you did your multiplication of fractions correctly, you know you can reduce before you multiply. And we would end up having the probability of pulling a purple marble and then a red marble would be 1 out of 48. Which is 0.02, which is 2%. All right, the probability of a purple, then a green marble. All right, so purple, again, is 1 out of 12. We're replacing it. Probability of a green marble is 3 out of 12. So we're going to get the exact same thing. 1 over 48. Now, I'm going to go ahead and multiply differently here for those of you that don't understand how to cross-reduce. I'm going to say 3 over 144. Then I'm going to divide the numerator and denominator by 3. And that's how I get my 1 over 48. All right, and then it's going to be 0.02, which equals 2%. A red, then a yellow, and I believe your paper, I took away then another yellow. So the probability of a red marble is 3 out of 12. The probability of a yellow marble is 5 out of 12. All right, I'm going to go ahead and do that cross-reducing again. I get 1 and 4, and it's going to be 5/48. 5 divided by 48 is going to be 0.104, which is 10.4%. Okay, so that's independent probability of compound events. Now we're going to talk about dependent probability of compound events. All right, so basically the probability of the second event is dependent upon the first. All right, so it says 3 blue, 2 yellow, 1 red, and 3 green marbles. So that's 3, 4, 5, 6, 7, 8, 9 marbles. I know I'm starting off with 9. It says, what's the probability of choosing a green ball from the bag? Well, ball, bat, marble, whatever. So we're going to choose green. Its probability is 3/9. Not replacing it. So that means that my bottom number, I started off with 9 marbles, but I'm not replacing it. So my number is going to go down to 8. And then not replacing it and choosing another green marble. So then, because it said choosing a green marble the first time, I'm going to assume that I actually got a green marble when I picked that first one. So my top number also goes down. Now, if it said green and then yellow, that wouldn't be the case. But since it says green and then green, then we have to assume that our first probability actually did occur when we write out our second probability. So I'm going to end up with 6/72. And that can be divided by, I believe 72 is divisible by 6. Yeah. And that's going to be 1/12. And 1/12 is, we already did that, 0.083 repeating, which is 8.3%. 0.3%. Okay. So let's take a look at this bottom problem here. Okay. There are 4 yellow, 3 purple, 1 green, and 1 white. So that's 4, 5, 6, 7, 8, 9 marbles all together. All right, starting off with 9. Once a marble is drawn, it is not replaced. That's why it's dependent. Our probability is dependent upon what happens the first time. So the probability of choosing a purple marble, there are 3 purple marbles. We're not replacing, so our bottom number goes down to 8. And then a white marble. All right, a white marble would be 1. So we multiply across and we get 3/72, which that is divisible by 3. And I get 1/24, which is 0.04, which is 4%. I'm rounding my decimals. Okay. So then it says 2 purple marbles in a row. All right. So again, we have 9. Purple is 3. The second number, we're going to assume that we got that first purple marble. So I'm going to change my number to 2/8. 3/9, 2/8. We just did the very similar math up above, which is going to be, I'm looking at this problem up here. Okay, the math is already done for us. So I'm going to say 1/12, which is 0.083 repeating, which is 8.3%. Yes, I am giving all my answers as a fraction, a decimal, and a percent. 2 yellow marbles in a row. Okay, so we have 9. There's 4 yellow marbles to start off with. We're going to assume we got that first yellow marble, so it's going to go down to 3/8. Here I can do some reducing. All right, that 4 goes into 8 twice, 3 once, 3 goes into 9 3 times, which I get. Now I multiply and I get 1/6. Which is 0.167, which is 16.7%. Okay, on to the back. A ball is picked randomly from this box. All right, we can see what this box has. It has 3, well, you probably can't because it's black and white. Sorry about that. It has 3 blue, 2 yellow, 1 red, and 3 green. Okay. What is the probability it is replaced, it says, okay? So we know that we have a total of 9. It says, what's the probability that both are green? All right, so we pick a ball. It's 3 out of 9. We pick another one. It's still going to be 3 over 9 because we're replacing that ball. Neither of our numbers go down. So then I end up with 9 over 81, which is 1/9. Okay, the probability now, if it's not replaced, we have 3 over 9, and then we have 2 over 8, which is 6 over 72, and we get 1 over 12. So it says, what's the difference between the two probabilities? I'm going to be honest with you. I'm going to say that the probability when you don't replace it is less, but I actually have to turn these into decimals to make sure. Okay, so 1/9 is 0.1 repeating. All right, 0.11 repeating. 1/12 is 0.083 with that repeating. So that's going to be 11%, and this is going to be 8.3%. So I would say that the probability when you replace it is actually better than if you don't replace it. Okay. So go ahead and write that here. The probability when you replace it is greater than when you don't replace it. And then what I want you to do on your own is answer this last question, okay? It's talking about choosing a pair of black socks, and what type of event is this, okay? All right, thank you.